Okay, thanks for staying for the nerd session before lunch. Great. So it's about Haskell R and Haskell R. Before I start, just let me say something about myself for the context, because it's a bit of a strange context. So who am I? My name is Sigrid Kajdana. And if there's one thing to say about me, it's really, if there was a competition for a number of career changes, I'm a good candidate for that. So if you think you need some regular imposter syndrome, just ask me after the session how to do it. I can tell you about it. And okay, what am I doing now? So I'm a data scientist and machine learning expert at Trivades. We're an IT consulting company in Switzerland, Germany, some other countries. I'm doing mostly deep learning at the moment, and now you will be asking what's the connection to the talk. Well, the connection is, as I say on my LinkedIn profile, oops, this was not that, but I'm kind of a functional programming aficionada, but not enough time. So I'm not doing it for a living, but I'm loving it, so to say, yeah. Now, let's get started. Now, what you're expecting, I guess, at this moment is to see the pipe, right? Now, it looks a bit like, do you see it, this thing? It looks a bit like, but it is not, so it's not the pipe here. But you see some behavior, oh, okay, better, which is like the pipe behavior, yeah, get something from input and print something to the output. Okay, so that's not a pipe, and if you use per, perhaps you know there's a compose function in there. Actually, this is not it, right? So this is function composition. But it's not R, right? So the R, for comparison, the R stuff would be this here. You would have to write this compose. Yeah? So there you have this elegant chaining with the dots there. And a third example, perhaps you know the partial application in Per, which is available there. And this would look like this, not in Per, yeah, but very elegant. And this would be the R version. So what is this, if it's not pipe and so on? Well, this is Haskell. What is Haskell? Haskell is a pure, meaning with isolated side effects, strongly typed and lazily evaluated language. It's a very elegant code, so I mean, you can always argue about what's elegant or not, but I think it's extremely elegant, and mostly it reads like a description of the algorithm itself. It's also widely used in industry. If you go on that link, actually you can see lots of companies which use it. It's used in financial and trading systems, real-time applications, all kinds of meta programming, strongly parallelized systems, because with Haskell it's actually easy to do parallel computation, web applications, cryptography, and whatnot. So lots of applications. Well, okay, now, if Haskell is such a great language, then what even is the problem? Well, problem is some things are really hard to do in Haskell, so, or even not implemented. Again, here, it's interesting to follow this link, because it really shows what's easy to do and what's not easy to do in Haskell, and how many libraries there are, what libraries there are, and so on. This is also continuously updated. So what is not easy to do in Haskell? Well, machine learning, one thing. Data science. And very important, of course, visualization, right? And all these things is, of course, what R is great at, right? And so what can you do there? Well, some very cool guys, what they did was they built Haskell R. So this was built by a company called Twig.io. So I think it's pronounced like that. They're mainly resident in Paris, but all over Europe. So a startup company doing functional programming. Very cool stuff. And what this is, it's an embedded R interpreter in Haskell, which is this inline R module. It's also an interactive prompt for evaluating Haskell as well as R code. And it even has a Jupyter Notebook integration, what we're going to see very quickly. So just before I start with the demo, let me say what is it in a nutshell. Well, it does not do any marshalling or unmarshalling of arguments, so the values are just pointers to these as expressions, as in R itself, so it's fast too. The R capabilities are provided by hosting an embedded instance of the R interpreter, and everything's happening inside the R monad. So perhaps you have heard this scary monad before, so there's lots of monad tutorials on the web. So this is for keeping the state around, right? So between calls to the embedded R interpreter, the state is preserved. But that's already enough of theory. Actually, already I can't run around now anymore. So can I just use this now? Yeah. Do you hear me like this? Okay, great. Then I have to switch here to the demo. So I am doing it all in Jupyter Notebook because this is so convenient. I hope you can read it. Okay. Yeah, okay, thank you. So there's a little bit of configuration I have to do. So this is just these 3 lines. So I set some language extension, and I do an import and initialize the whole thing. And now the base code is Haskell, right? So this is an iHaskell notebook. So it's basically Haskell. Now I am evaluating this here. And now the first thing I want to show is how do I do things in R. Now, okay, this is the first thing you see here. We have this embedded R in there. So this is called quasi-quotation in Haskell. You have these brackets at the ends here, and also these pipes, yeah, so pipes in the Linux language, not R. And in here we have the R code. What I can do now is I can just evaluate this thing, and I get printed the R output directly here in the notebook. I cannot only print stuff, I can also plot stuff. For example, here I'm doing a simple plot with ggplot2. Here, in this case, I have to write rgraph, not rprint at the beginning. And I'm doing this. And now I just here get a nice plot. What about assignment? Because I don't always have just one line only. Well, I can also do assignment as normally here in R. So I'm writing a short factorial function. So if I do this, as you see, I get the factorial here. Now, I'm going to call it again now. Yeah. And okay, so it could not find function fact. What happened? Well, I can get this preserved state, but what I have to do is I have to use this global assignment operator here. And then you see it works. Okay, but the scenario is mostly my application is in Haskell, right? Because I'm doing everything in Haskell and I want to use R to do the fun stuff, so to say. How do I ship over my data from Haskell to R? Well, for that I use this _hs suffix. So here you see an example. I am having a list in Haskell here. This list from 1 to 10. And now I am printing the mean of that in R. So I have to suffix it with this _hs, and like that I get it. Now I can even do this with functions. So here I am defining a function in Haskell. This is the factorial in Haskell now. I have to define a wrapper to put all this in the R monad. And when I do this, well, in the next step, I'm just going to call this in R. So, as you see here, so it works. So this was one direction. How do I get things from Haskell to R? Of course, I also need the other way around, which is how do I get things from R to Haskell to continue working with it. What do I do? Well, I'm not going to explain the whole syntax here, but just show it. Here I have my values back in Haskell. I can show this because when I do evaluate this here, I get a Haskell data type. So this is in principle how it works. Now let's do some applied scenario. So imagine we are a company doing something in the stock market, a trading application, and of course we're interested in doing all the cool R stuff that R provides and would be different and difficult in Haskell. So we do the setup again as before, and I am loading some libraries. I'm doing it at the beginning already. And of course, in my scenario, I have lots of stuff going on in Haskell. Here, I'm just reading in some data from CSV files to show it, right? So this is, I'm doing this, I did this now. And now I can just do some data exploration. What do I do? Well, as usual, for an R person, I am using ggplot2 and just graphing the stuff. And so I see I have 3 lines and have this nice time series plot here, which is really a nice and easy way to get the stuff here. I can even do some further analysis, like looking at autocorrelation functions, which I did here, you see, and which is incredibly convenient, I think, for if you come from the Haskell background, you can just quickly do an auto-arima, so 3 lines of code, here it is, and get a forecast. So very convenient. But of course, everyone's doing deep learning now, right? So, and there are, from Haskell, there are bindings for TensorFlow, but as we have this Haskell R, we can also directly use Keras, because we have the Keras binding from RStudio for the Keras Python framework. And this is what I'm gonna do. So we need to check for the TensorFlow installation. Do this first, just to be sure it finds it. There's lots of stuff, so this is fine. And, okay, do much? Okay, that's great. So we have lots of time. Then I have to quickly prepare my data for the deep learning network I'm using. So I'm using a long-term short-term memory network. I'm doing this here now, so I've transformed my data for that. Then let's quickly check about the model. We don't have any model yet, and this will be the next step. So I think okay, this star shows it's running. In this Jupyter notebook, sometimes at this point it hangs, yeah, and I know that, and so I'm prepared for that. So I switched to another version of the same thing, and I'm just showing it now. So this is how it actually looks. So I define my model here, you see. Here it is actually. And then I train my model. Actually, this I wouldn't do live anyway now. So I trained my model, and then, okay, sometime later, scroll down. Okay, then I'm doing it all in R here, you see, and I just plot the results, and let's look at the forecast. And yeah, actually it looks quite nice, I think. It's on the training data, yeah, because it's a play case. Yeah, of course I would use a test data for that normally, but it's to show the technique. And yeah, well, so I think this really nicely shows the value of using R from Haskell, so combining the best of 2 worlds. Thanks. Questions?
Yeah, first of all, thank you for featuring my most favorite language I never used for anything serious. And just one addendum, I think it's quite an interesting feature of Haskell is that it has arbitrary integer precision built in out of the box. And that could be something if you have to work with large integers, and that's also why it's used in cryptography, that might be actually useful for somebody who has something to do with statistics or mathematics. So just as an addendum.
Well, let's join me in thanking our 4 speakers.